Hi y'all, I wanted to work out a problem with you today over stoichiometry. So we already have our balanced equation here. We have 2 moles of potassium chlorate decomposed to produce 2 moles of potassium chloride and 3 moles of oxygen gas. Please forgive that the subscripts did not transfer over as so, but I think you should realize that the 3 with the oxygen on the potassium chlorate should be a subscript, as well as the 2 associated with the oxygen on the product side. So let's look at our question. So this says here that we have 1.50 moles of potassium chlorate and it decomposes. How many grams of oxygen gas will be produced? So we have a balanced chemical equation, but yet our question will lead us to the parts that we care about for this. So we always have a given, and then we always have something that we're trying to find out. Our given is always going to be some numerical information. So we know here that we have 1.50 moles of potassium chlorate. I'm going to go ahead and just circle that in my balanced chemical equation as well. It decomposes and it wants to know how many grams of oxygen gas will be produced. There's your question. That's what you're trying to find out. How many grams of oxygen gas? So I'm going to go ahead and circle that as well. Oops, sorry that it missed. Now, lots of you have been asking, well, Miss Gordy, how do I know which one I need molar mass for, or which order to go in? And you know that by looking at the type of units that are with your given and the type of units that are with your find. So if we look here, our given, and we'll just go ahead and write this out to the side, is 1.50 moles of potassium chlorate. We know that we are trying to find how many grams of oxygen. Okay? All right, so we definitely know we're going to need mole ratio for this problem, so we know that our mole ratios for every 2 moles of the potassium chlorate that decomposes will make 3 moles of oxygen gas. So we'll just go ahead and pull that to the side. 2 moles. Oh goodness, y'all, just learning how to write with this, okay? Is 3 moles of O2, okay? Now, so we see that our given is already in moles, and anytime you're in the language of moles already, this is the language of how chemistry functions. If you're already in moles, you don't need molar mass. So anytime you're starting in moles, you're ready to jump right into the balanced chemical equation and pull that mole ratio. But look at what we are trying to find. This wants me to express my final answer in grams of oxygen. So now that there's a G or a grams associated with my O2, I'm going to need the molar mass for O2. Okay? So we're going to go ahead and add that up. So for every mole of O2, that should be 32.00 grams. Okay? We don't need the molar mass for potassium chlorate because it's already in moles. It's already in the language of chemistry. It's ready to speak to that balanced chemical equation. I think we have just about everything we need here. This is a mass mole problem, all right? And in this case, we're starting in moles and we're going to end in grams. So let's go ahead and get started. We've got 1.50 moles. Uh-oh, sorry y'all. That looks terrible. And we're going to go ahead and plug in our mole ratio first. We're going to convert over to oxygen, and we want to cancel out moles of KClO3. So we definitely need potassium chlorate in the denominator. And we're moving into the oxygen, so we want that to be in the numerator. Now it would like me to express my final answer in grams of oxygen, and I need to cancel out moles, so that means I can go ahead and cancel that here. I need to plug this in with 32.00 grams in the numerator because I'm trying to end in grams, and 1 mole of oxygen in the denominator because I'm trying to cancel moles of oxygen. I'm ready to crunch numbers. Always double check your work. So that's going to be 1.50 times 3 divided by 2 times 32. I got 72, but I'm gonna do that one more time. 1.50 times 3 divided by 2 times 32. I got 72 again, but I need to account for significant figures. So I would have 3 significant figures in 1.50. That means that I would need 3 significant figures in my final answer. So I'm going to add a decimal place and a 0, grams of O2. All right, thank you.